Cool. All right. I'm going to show like a kind of a different take on what some of the things that actually David showed, which is a different ecosystem that supports a whole lot more environments and actually makes it easy to do things that David said are hard in WebAssembly. And that's largely based on this project that our company works on called Xdism. We started the company around this project with the goal of making all software programmable. And by programmable, I mean extensible. I mean letting your end user change the way the software works, build plugins into that application, and then you safely and securely execute that untrusted code, finally kind of like getting runtime eval, but safely and without all the scariness of doing that like we've been taught not to do. In fact, we even named the company Dylibso as a kind of a hat tip to don't just load untrusted precompiled code inside your app. WebAssembly actually now makes that safe to do. And there's some other protections and guidelines and things that you should do too that we take care of for you. But I'm not going to talk entirely about Xdism today. I just want to also mention a couple other projects that are relevant to some of the things I'll mention. We build an entire observability stack for WebAssembly to actually profile and instrument your WASM code and make it easy then to emit open telemetry out to any kind of collector and then get observability in places like, why is my tab not moving? Oh, probably because I chose just a tab. Cast the screen. Okay, there we go. This is a Browsertech meetup, right? So we're fully immersed in browser technology today. So yeah, we build this observability stack for WebAssembly, which includes a set of libraries to instrument your WASM code and an automatic instrumented compiler that'll take uninstrumented WASM code in and spit out fully instrumented WASM code. You then use a library to kind of adapt your WASM runtime to be able to hook into those telemetry events, and then you can actually finally get full profiling and traces out of your WebAssembly code and kind of fill in those long, sad single lines inside of like your distributed trace. We have things for Datadog, for Honeycomb, for pretty much all the big observability platforms. We also work on a Java native runtime, which is fully WASM spec compatible, and also runs in an ahead-of-time compiler mode, which will translate WASM bytecode to JVM bytecode on the fly. So your WASM runs just as fast as your Java code does inside the JVM, and you don't link any native runtime. So bye-bye WASM time, don't need it. You can just use Chicory inside of your JVM apps and benefit from running WASM code inside of Java. So on to the main event. I'll talk very briefly about a commercial product that we just released a month ago called XTP, which is kind of like the day two operational platform of Xdism. If you actually want to run a production-ready plugin system inside your app, getxtp.com is your friend. But we do a whole bunch of open source tooling that XTP platform uses, and that's what I'm going to show off tonight. And just to get into it quickly, the idea was XTP is really meant more for like back-end applications, and I want to run customer code inside my back-end logic. And I thought, this is a browser meetup, I got to figure out a way to put it in the web. So we actually have a little SQLite demo here, and every time I run a plugin, I'm going to pick just this one that happens to be written in Zig. It instantiates a new SQLite database in memory, and then the Zig code makes some calls to that WASM database, that database that's linked over as an import to that WebAssembly module. And you can see it just generates some data, inserts some records into the database, and then pulls them back out. And this is all driven off of what we call the XTP schema. David mentioned a format called WIT. I think it actually is more like a word that rhymes with wit. This is a little bit more sane. It's actually lifted just from OpenAPI, which pretty much everybody's familiar with. You describe your types that go across the WASM boundary in a familiar schema format, and you can reference types. You can describe rich schemas you can describe the imports and the exports that the WASM code either depends on functions from the host environment, or that it exposes to the host environment to call inside the WASM. And we've implemented XDP schema with a series of code generators that are also all open source in a bunch of different languages. And I will get to show how that works. Let's see. So XDP has a CLI. You can just download this and write XDP plugin in it. And I got to pass a local schema file. This is all offline. Typing with one hand is a little bit harder than I thought it would be. Oops. There we go. And you can choose from one of the languages that could generate the guest code, the binding code, in all these languages. So we'll pick something you didn't see yet. Maybe we'll do Zig. And it generated a plugin scaffold for me. Here. We'll look at one of these empty, then I'll show you a bunch that are already kind of filled out and show you how they work. But we see that execute function, which you saw in the schema. It takes an input of this execution context, which is just some data to give the plugin before it maybe interacts with the database. And it returns an execution result. We have a JavaScript app, which you saw in action there. I'll just quickly show that so this makes more sense. And the important parts are here, where we link this one import into the WASM code called query, which just runs a query against the database, unsurprisingly. And it puts some data into the WebAssembly module, which you can see back here by storing the output of calling the query onto the actual SQLite database that's running inside JavaScript. And then it calls the plugin. And this plugin is just loading that WebAssembly code from that file input using the byte buffer, and sets up some options for XSysm to then create the WASM plugin. It needs to use WASI. It takes that import function here, and then just sets up some other information, like what logger to use and what level to log out of the WASM code. And then alternatively, you can optionally pass in some override data, and I'll show that in a second. And then we call that execute function from the plugin, passing in just the kind of the stringified JSON of this input. So back to that plugin, we have just the boilerplate. Oops, where are we? What do I call that thing? Here. Which is pretty uninteresting, except for the fact that you don't see anything but Zig here. There's nothing about any kind of WASM linking or anything that's out of the ordinary. It's just normal Zig code. To look at this thing filled out, we have this one here, which just sets up a couple SQL queries. One to create the tables, one to insert some data, one to select that data back out. We've got this host function, the import query, which just takes a Zig struct, the query that you want to run, and that creates the database tables. We do some checks to see, hey, did I get that input data from the host? Are there some names to use? And if not, I'll use these kind of Zig-specific ones that I want to show in the UI. This is pretty bad Zig code, by the way. I'm not a very good Zig programmer, but I'll show you a bunch of other languages that work too. The same thing, if you want to see what a TypeScript version of this looks like. This is also boilerplate, just using the XDP plugin init function, generating a TypeScript plugin, filled out, says, great, I'm going to use these TypeScript names. I will check to see if the host provided me any data. I will then run the query to insert that data, select it back out, and then return it as some JSON conforming to this execution result type. And I'll just show that really quickly. We'll override, well, you know what, we'll leave this one here. Plugins, TypeScript. So now we see, of course, the TypeScript stuff. What I mean by like overriding those names is I'm just going to use JS in here to show that the host is actually loading it. And then you can see that time it actually had the host provided data in there. Same thing goes for Rust. We support generating Rust bindings. So this all is just familiar, fun Rust code. Again, sets up the database tables, checks if there's input, otherwise uses these Rust names so you can tell it's coming from this particular code, runs the query to insert the data, runs the query again to select it back out, passes it back onto the output. And let's see here. This one's in a different file because Rust is awesome. Oh, yes. There we go. I could repeat this in every single one of these other languages. You can see the boilerplate in Go. You can see the boilerplate in C++. You can see the boilerplate in Python. You can see it in Haskell. You can see it in C#. The point is that by choosing a much more straightforward, simple, and familiar interface language like OpenAPI, we, as a very small team of 7 people, have been able to generate more like code gen than the entire Bytecode Alliance has for the component model in several years. So if you want fast, functional, useful today, check out XTP. That's kind of a talk. Yeah, so thanks.